welcome to my channel. I'm in coaching center. So today I'm going to explain your 12th standard physics 11th chapter, that is real nature of radiation and matter. Nature of radiation and matter part 2 video. So let's come to the chapter. So our next topic is particle nature of light, the photon. So is the light quantum of energy to be associated with the particle? So Einstein arrived at the important result. So Einstein gave the important result that the light quantum can also associated with momentum. It can also associate with momentum, and the definite value of energy as well as momentum is a strong sign of the light quantum can be associated. It is the strong sign that tells us that we can associate the light quantum. So we can summarize the photon picture of electromagnetic radiation as follow. Like this we can summarize. So how we can summarize, they can ask in your final exam. So let's know. The first thing is we have to do in the interaction of the radiation with matter. Radiation behaves as if it is made up of particle called photons. So radiation reacts as it is made up of particle of photons, and also each photon has energy E and momentum P and speed C and the speed of light, and also all the protons of the light of a particular frequency V or wavelength lambda have the same energy E and the momentum P. All the photons have same energy, and also photons are electrically neutral and not deflected by electric and magnetic waves. So they are electrical neutral and not deflected by electric and magnetic field. And in photon particle collision, photon electron and the total energy and the total momentum are conserved, and however the number of photon may not be conserved in collision. So these are the things observed by Newton in the making of in the particle nature of light or the photon. Next is wavelength nature of matter. So the dual nature of light in the light comes out clearly from what we have learnt in the and the preceding chapters. The wave nature of the light shows such a phenomena of interference, diffraction, and polarization. It shows, and the French physicist, that is Louis Victor de Broglie, put forward in the bold hypothesis that moving particles of matter should display wave-like properties under suitable conditions. So what he did means, he said that the wavelength is lambda and momentum p is given, he gave, and lambda is equal to h by p is equal to h m into v, and also he gave the equation, and after that this is called as Broglie wavelength. The lambda of the matter wave is called as the Broglie wavelength, and then the equation is p is equal to hv by c. Therefore h by p is equal to c by v is equal to lambda. We will get like this. And let's know about the question they have given. Lambda is a smaller for heavier particle or more energetic particle. Broglie wavelength of a ball mass 0.12 kg moving with a speed of 20 meter square is equal to, calculate, let us calculate. P is equal to mv is equal to 0.12 kg into 20 meter square is equal to 2.40 kg we will get. So therefore lambda h by p is formula, so is equal to 6.63 into 10 to the power minus 34 by 240 kg. Here we got not 12 into 2, and that is 240 kg we got, that we will put, and here 2.76 kg the formula we will put like that. The wavelength of the small this we will get, when we solve this we will get 2.76 into 10 to the power minus 34 we get. So like this we solve the question. So next let us take k is equal to 1 by half mv square is equal to p square into 2m. So this is h for h formula. Here we got that is h formula we have taken, and this by 2.40 kg here we calculated. So therefore lambda is equal to that h by 2.40. So therefore the answer we get is 2.76 is the moving speed the wavelength we found. Next is here lambda is equal to 1.227 by root v nm. So therefore, yeah, and also this by crystal diffraction experiment analogous to X-ray diffraction also found, and the matter wave picture elegant incorporate the Heisenberg uncertainty principle. According to the principle, it is not possible to measure both position and momentum. So according to them, it is not possible to found both momentum and position. So therefore, the product is after that there is also some uncertainty in the position and some uncertainty in the special momentum. So therefore the product is the delta x and delta p is the, so therefore delta x and delta p is equal to h. We get h, the other scientist said. And after that, wavelength extends all over space by bonds, probably interaction. This means that the electrons is not localized in any infinite region of space. It is not in any finite region of space, and in general the matter wave associated with the electron extends all over the space. It also extends all over the space, and it is a wave packet extending over some finite region of space. And in the case lambda x or the delta x or the here we came to know that is it is a uncertainty of the position. We came to know that is infinite but has some finite value. So it is infinite but has some finite value. By the Vogel relation, then the momentum of the electron will also have speed any uncertainty, and they expected that there may be and probably interaction reproduce, and hence per uncertainty principle exactly remain. And we will learn about Vogel relation in chapter 12. You will learn. I will explain that chapter. Next is derivation and Germer experiment. So what it means? What means in two scientists C.J. Davison and L.H. Sherman in 1927, and independently by G.P. Thomas and by another scientist C.P. Thomas, who observed diffraction effect with beam of electrons. So they observed diffraction in the when they left the beam of electrons scattered by crystal. So beam of electrons in crystal, and they both shared the Nobel Prize they got. And the experiment arrangement used the Davison and Sherman in this like this in 11.7. You can see like this they arranged. So they had a tungsten filament coated with barium oxide and heated by a low voltage power supply. That was heated by a low voltage power supply, and electrons emitted by the filament or accelerated or desired velocity by applying suitable potential voltage from the high voltage power supply. By giving suitable voltage for that from high voltage supply, they are made pass through the cylinder with the holes along its axis, producing a fine collimated beam, and the beam is made to fall on the nickel crystal. They kept a nickel crystal where they see here on nickel crystal they made to fall the beam, and from there the electron beam scattered and given direction and measured the electron detector, and the detector can be moved on a circular scale. The detector, so here the detector can be moved in a circular square, and also the variation of the intensity of the scattered electron with the angle of scattering theta is obtained for different accelerated voltage. So therefore what they have did means in the experiment was performed varying the accelerated voltage from 444 volt to 68 volt. They were giving the voltage. So therefore the scattering angle theta is equal to 50. So from the electron diffraction measurement, the wavelength of the matter wave was found to be 0.165, and therefore V is equal to 54 they take. So therefore the formula that we got here, this formula we got now, lambda, that formula So by putting that lambda is equal to 1.22 by 7 into root 54, so therefore we get 0.167 meter. So this for the Broglie hypothesis has made basic to the development of the modern quantum mechanism. He gave the contribution for the development of the quantum mechanism, and you will learn more about it. So okay, this was your chapter, the dual nature of radiation and matter. So okay friends, I think you understand this chapter. So I will explain the next topics in the next video. Okay friends, like the video, comment on my video, and subscribe my channel and my coaching center for more video. I will explain the next topic in the next video. So till then, take care, see you, have a nice day. Bye my friends.